Hey guys, Mr. B here. On this portion of the virtual radiometric dating lab is about the post-lab questions and doing the data. Alright, so at this point you should have read through all of this stuff, you should have watched the video, and you should have numbers written down in your data table. Okay, so I'm going to pull up the data table here real quick because I haven't done so yet. Okay, so we're going to click on this, we're going to make a copy, and I'm going to write in the numbers, which you should already have written down in yours, but if you don't, I guess you can write them down here as well. All right, so on our data table here, in run number 1, we had 19. In run number 2, we had 13. In run number 3, we had 6. In run number 4, we had 1. And in run number 5, we had 0. Okay, now it's going to make a graph here automatically for you. So we're going to go back to our virtual radiometric dating lab. And we're going to take that data table that we just made and put it inside our Google Doc, okay? Now there's some instructions here on how to do that, but I'm going to show you how to do it anyway. All right, so it says select insert from the toolbar above. So we're going to select insert. Select chart. So go down to chart. From sheets. Select the Google Sheets of the data table you're just typing on. So this is going to come up, and we were typing on this virtual radiometric dating lab handout, so we're going to select that one. There's a chart right there, so let's click it and hit import, and bam, there's our graph. Okay, so that's the same graph that we just made on the other Google Sheets here. Perfect. All right, so it says after the graph is plotted, think about and answer the following questions. All right, so first question here says, how can you use your graph to determine the age of a fossil? If it were made out of uranium-235, it was decaying into Pb-207. Okay, so imagine that this graph here is in percentages, right? So represent here in the very first one is 100% uranium. And then, halfway down is about 50%, and then 25%, et cetera, et cetera. So if we wanted to, we could use this graph to determine how many half-lives have occurred in like a fossil by kind of plotting our own data and then like getting a percentage of the fossil and looking on our graph. So let's say we found a fossil that was like 50% uranium. We could look on our graph here and go, okay, so 50% is roughly about here. And if we go over to the graph, we can see like how many half-lives have happened. At that point, it might be like 1 or 2 or something along those lines. So we can say we can use the graph and look at the percentage of U-235 in the fossil and find on the graph how many half-lives have occurred. Okay, something like that. All right, number 2, if you found a fossil that only had about 12% of uranium-235 in it, how many half-lives would you estimate had taken place? Okay, so let's do some math here real quick. So imagine that at 0 half-life, not O, 0 half-lives, okay, we have 100% uranium. At 1 half-life, we now have 50% uranium. Okay, at 2 half-lives, we now have 25%, right? So we notice it's going down by half every time. At 3 half-lives, we would have half of 25, which is about 12.5%. So for number 2, if you found a fossil that only had about 12% of uranium in it, how many half-lives would you estimate had taken place? About 3. Okay, so we would estimate that about 3 half-lives have taken place. All right. So this last part here just kind of shows you sort of how to use these graphs. So it says uranium-235 is found in most igneous rocks. Unless the rock is heated to a very high temperature, both the uranium-235 and its daughter, Pb-207, remain in the rock. A geologist can compare the proportion of uranium-235 atoms to lead-207 produced from it and determine the age of the rock. So here would be like a graph of half-life. On this y-axis, we have 100%, 80%, 60%, 40%, 30%, 20%, all the way down to 0. And on the bottom, we have millions of years. So a rock that's, 49% uranium, we can go over here from the 49% until we hit the graph. go down and see how many millions of years have occurred, about 704. If it's about 24%, we can go over again till we hit the graph. Go down, we have about 1,408 million years. That would be 2 half-lives. Okay, so this graph here that they have on this little portion is sort of like the graph that we just made here. We didn't graph percentage on this y-axis, but we could have. And we didn't graph millions of years on the bottom. We graphed number of runs or half-lives. But if we know how long one half-life is, which earlier up in here, it does tell us that the half-life for uranium here is 704 million years. So every single time that we had one run go by, that would be 704 million years. And we could use our graph to also determine how old a fossil is, just like you could use this graph here. All right, guys, that is it for the post-lab questions. That's it for this lab. Hopefully you learned a little bit about radiometric dating. And again, as always, if you have any questions or need any more help, feel free to email me. Okay? Don't mind asking and reaching out. All right, that's it. I will see you in the next video.